to the online students.
Oh, kalau ini ya, mulia tentang.
So, is it visible? So, links a double slit experiment. So, to understand this, so Young's double slit experiment. To understand this, we need to just have a brief idea about interference of waves. Okay? Interference of waves. Already we have discussed that when two waves interfere, uh, constructively and destructively, the resultant amplitude and hence intensity expressions we have discussed already. So you have to remember this. So here what you will what you are trying to understand is when two coherent sources means the waves which are having same frequency and same phase or constant phase difference are called as coherent sources. How can you produce coherent sources is if you usually frequency depends on source. If you get two beams from a given source, then they will have same frequency. So if the light coming from a given source, if you are allowed to pass through two different slits, then these light rays or light beams here we have to treat it as waves. So to the light waves which are passing through S1 and S2 behave like two different sources having same frequency. If you maintain the phase difference, constant phase difference, so that when you have to just keep in mind the what you call the conceptual part of interference. If you remember here, this is one slit. You can understand this in this way. This is slit S1. This is slit S2. When light is passing here as a wave, it will propagate. It will advances forward like this. Okay, and here the light coming from this also advances as a wave only, so you can understand how this waves will go forward like this. They can say this also advances in this fashion. If you observe these waves here, this and this, somewhere at these positions, somewhere here if you arrange one screen, somewhere here if you arrange in screen, you can observe some experimentally it is observed that when two waves are allowing to pass through, it is observed that bright and dark spots on the screen. Why this has why you are observing this bright and dark spots when you are allowing the same light, same you can say frequency light and same wavelength light, same colored light. You can say, one more thing, you can use monochromatic light to avoid some what do you call mismatch, what do you call intermatch, inter mixing of colors. If you are using white light, you will come across some kind of mismatches. So to avoid that confusion, so it will be better to use monochromatic light, single color light. Monochromatic means single color at single wavelength light, and hence frequency will be fixed from a given source. And with the help of this, we will observe number of fringes or bands, you can call them as. Like how these bands are observed is, when a bright band is observed at the center point. If this is S1, this is S2. For the midpoint of this, if you consider something here, if I draw a line, at this point it is observed that a bright band is formed, a bright band. Then it is observed that a dark band is formed. So this side, both up and down or left and right. Then again, bright bands are formed. Then again, dark bands. Then again, bright bands. Right? Likewise, alternate dark and bright bands are observed on the screen. To explain this mathematically, some simple mathematical relations have given. So those are nothing but, now you can see, come here, by understanding by attributing few properties to this setup as an experimental arrangement. The experimental arrangement consists of two slits which are separated by some distance small d, and these slits are separated with the screen by a distance of capital D, where capital D usually will be much greater than small d, or small d will be much less than the capital D. So it will be in millimeters range. Usually the distance between this will be in meters range, 1 meter or 1.5 meter, like that, in meters range. So it will be very very small. And in such case, when you allow some light to pass through here, already you have some idea that the waves are passing. You have to just imagine, when you're when you consider light is traveling here, means you have to imagine a wave. Okay, like you can imagine a sinusoidal wave also. Okay, so when a wave is traveling here from S2, and if it is reaching some point P on the screen, another wave is traveling here as like a sinusoidal wave, just imagine, and it is reaching here. If these waves in not only here, if you consider this point, exactly the point on the screen, which is obtained by drawing a line from the midpoint of the slits. If you consider here, the wave from here and the wave from here are observed to be traveled the same distance, equal distance, same path length. You can say distance means path length.
Sir, which one?
The one from S1 on to here, you can consider the other way. So this is S1, this is S2, distance between them is D. So from the midpoint of this slits, you draw a line, and this is your screen. So if you say this is O, the wave from here travels some distance or a path length and reaches this point. Here, the wave from here also travels some distance and travels this path. It is observed that the path length traveled by these waves from to reach the exactly center point, the point here, the midpoint or center point, corresponding center point, are equal path lengths or equal distances. Then, if you consider a wave in this distance or path length, equal number of waves will fit. What does it mean is, if one wave is fitting here also one wave will fit. So that if this wave here, after coming here, is a crust of this wave is going to start, means for this also crust will start, means both crust and crust will join, means you will get constructive interference, means maximum amplitude and hence maximum intensity, and hence you will get a bright fringe here, and hence you will get a bright fringe. Whereas if somewhere here, if you observe, as a experimentally it is observed that here you are getting some dark fringe, then again bright fringe. That means the wave coming from here to here and from here to here are, if you observe with another diagram, here for understanding purpose, this is S1, this is S2, this is screen, The distance between the slits and screen is capital D, and between the slits is small d. You have to always remember this, keep this in mind. Now, if you, if the, this is the line drawn from midpoint of the slits onto the screen. If a light wave is traveling from here to here and here to here, and if they are like from here to here, they are meeting here, obviously it is appearing like that, appearing that the light ray traveling from here to here and here to here may travel same path length, but here to here, and if you observe this, it looks like this is having larger length, path length. So if you consider this is path point P, path length of the wave traveled is little more than this. That means in this, if one wave is fitting in this, uh, more than one wave should fit. Because it is larger distance, in this distance more than one wave should fit. The more than one wave is fitting, that means that more is there, right? How much is that? Depending on that, we will observe here either bright or dark fringes. So to understand that, we draw a perpendicular line like from this point to here. And what it gives is, from here onwards, the distance, the path length of this line and this line will be same. That means the same number of waves will fit in this path length. So excess number of waves will here, maybe half wave or one wave or two waves or whatever it is, depending on the excess number of waves in this extra path, we can observe here either bright fringe or dark fringe. How we can say by using this to understand that? Let us try to find what is this. This call this as extra path, or if you see, if you take this is path length of this path length as S2p, this path length as S1p, S2p minus S1p will give you this path length. We call it as a path difference. So we take here from the figure path difference between these two paths is S2p minus S1p. It is denoted, we are denoting this as delta x. By symmetry, if you draw a line from the midpoint to on this point, as if you consider this is making an angle theta with horizontal, as according to this condition, d is much greater than small d. Okay, all these lines, the line S1p, S2p, and even if you consider this is OP, this is Q, so and QP, all will almost be parallel. So that means all we made same angle with this horizontal lines. So by symmetry, if you say OPQ is a triangle, right, then we can say that in this triangle, if this is theta, so by symmetry, this also makes this S2P line also makes an angle theta with this horizontal line. And because we are considering this delta x is extra path or path difference, for obtaining this, we have drawn a perpendicular line here. The line is perpendicular to this, means the angle between this line and this line will be 90. So this line and this line here also 90. So this is 90, and this is vertical line, this is horizontal line. This also will be 90, right? Then and this is theta. This is 90, this is theta. So what will be the angle between these two? So in this total 90, if you subtract this, you will get this. So this will be 90 minus theta, this will be 90. Then what will be this angle? This will be theta, because sum of the three angles will be equal to 180. This will be theta. So if this is theta, we can say that here S1, S2, we can give some name to this, some name M. S1, S2, M forms a right angle triangle. Here this is 90 degrees. So this side, which is making an angle 90 to this, and opposite to this angle, will be called as opposite side. So this D is making an angle theta with this side. So for this angle, this is opposite, this is adjacent, this is adjacent. So if you resolve this, D becomes D cos theta along this and D sin theta along this line. So here delta x, extra path length or path difference, is equal to S2p minus S1p is equal to delta x, it is equal to D sin theta. Now this gives us the extra path difference traveled by the wave in this path. If this extra path difference or path length in this path, if one wave is fitting, then how many waves are here? If one wave is here, here also one wave will be there. That means if one wave is here, similarly like one wave is there. Depending on this, actually, if you like to start here, if one wave already fit here, next the crust start here and one wave forms here, so the crust and the crust of this both will join here, so you get constructive or interference and hence bright fringe. Whereas if in this space, if only half wave fits, then remaining half start here. So the starting point is this. Here starting point is this. At starting point, a crust starts and then it rough ends can start here. Here, if half is crust starts, but a half wave fits here, the remaining half wave fits here. Then here you can say what will start here. Actually, supposed to be in this. If it is one wave is fitting, means here also one wave should fit. For that purpose, we have to say that this is a half wave. This is next half wave. One more half wave should come, and hence in this one wave should fit. So for half wave, one wave, then trough should start here. Because of this, crust should start here. Trough should start. And when crust and trough are joining, then you'll get dark fringe due to destructive interference. If half wave is here, and instead of half, 1.5 wave is there, 2.5 waves is there, in such cases also similar kind of interference will get. What is that 1.5 wave, 1.5 wave, 2.5 waves like this means? We have to understand this. A few more points here is that if you know, if this is a sinusoidal wave, then this will be considered as one wave and length of this wave is called as 1 lambda. And if it is half wave, length of this will be considered as lambda by 2. Now, in this extra path, if one wave is there, means path difference is equal to lambda. If one wave is there, two waves are there, 2 lambda, three waves are there, 3 lambda. Where one wave is half wave is there, means lambda by 2. 1.5 wave is there, means one wavelength is lambda plus next half wave is lambda by 2, so it becomes 3 lambda by 2. So 1.5 wave is there, means 3 lambda by 2. 2.5 wave means 5 lambda by 2. Like this, odd multiples of lambda by 2 are there, you'll get destructive interference. That mathematically you can understand here. If as we know, the phase relation between phase difference and path difference is delta phi is equal to 2 pi by lambda into delta x, and depending on this value, you can also consider here, or you can already we have discussed about what are the conditions for constructive and destructive interference in terms of phase angle. So phase angle for constructive interference was 2 n pi. What is it? Integral multiple of 2 pi, or n into 2 pi or 2 n pi. Okay, if you want to find the corresponding path difference delta x, you can write delta x from this is equal to lambda by 2 pi into delta phi. So delta phi into lambda by 2 pi. For constructive interference, delta phi should be equal to 2 n pi into lambda by 2 pi. Here 2 pi gets cancelled. Okay, 2 pi gets cancelled. You'll get n into lambda. You'll get n into lambda. So that will be the condition for constructive interference. What is that condition of path difference for constructive interference? The same thing we have understood here. For obtaining constructive interference, you should have one wavelength or two wavelengths, three wavelengths, like that. That is the meaning of this. N equal to 1 lambda, 2 lambda, 3 lambda. If these waves fit in this extra path called path difference, then you'll get constructive interference or bright fringe. That is the meaning of it. Next, for destructive interference. Already we know phase difference for destructive interference is 2n minus 1 into pi, where n is equal to 1 to 3 and so on. So the corresponding path difference can be obtained from this as delta x is equal to delta phi into lambda by 2 pi. Delta phi, if you can replace this 2n minus 1 into pi into lambda by 2 pi. Here pi gets cancelled, then you can write 2n minus 1 into lambda by 2. Lambda by 2, here n takes values 1 to 3 and so on. n equal to 1. 1 minus 1, 2 minus 1 is 1 lambda by 2. 2, 4 minus 1, 3 lambda by 2. Then 2 is 3 lambda by 2. 3, 5 lambda by 2. So for this means, for half wave, lambda by 2. 1.5 wave, 3 lambda by 2. And for 2.5 waves, 5 lambda by 2. For like this kind of extra waves in this extra path, we get destructive interference. That can be understood with the help of this mathematical expression. Right? For lambda by 2, 3 lambda by 2, 5 lambda by 2, that means like odd multiples of lambda by 2 path differences, we will get destructive interference. So you can say the conditions for this I have mentioned here without writing this. What is the condition for constructive interference in terms of phase difference is integral multiple of 2 pi. In terms of path difference is an integral multiple of lambda. integral multiple of lambda, that is n lambda. And the conditions for destructive interference in terms of phase difference is 2n minus 1 into pi. In terms of path difference, 2n minus 1 into lambda by 2. By 2, lambda by 2. That is the meaning of it. So these are few conditions you can understand in what you call Young's double slit experiment. Okay, fine. When the path difference is n lambda, you'll get bright fringe. It is equal to, when it is equal to 2n minus 1 into lambda by 2, you'll get destructive interference, means dark band. Dark band. So it is observed. If you observe, what is the position of the here for bright band n equal to 0, you'll get first bright band, we call it as the central bright band. Here beside this you get the bright bands on up and down like this, that already I have discussed, right? In this, if you observe, it is observed that they will be at equidistance. That actually I have not given the entire theory part here. That we can cross check what are the positions of the what they call bright bands, positions of bright bands and positions of dark bands. How to find where we will get position the bright band and where we will get dark band? We have to just need to we need to have an idea about next little more brief discussion here. Right, you see here, to understand or to find the positions of, to find positions of bright bands, to find position of or positions of, to find positions of bright band or bright fringe, band or fringe, any word you can use, to find positions of bright band or fringe, bright fringe or bright band, we have to just follow few points. One of those points is when you are getting bright band, when the two waves are undergoing constructive interference. That means when constructive interference is happening, what is the condition for constructive interference in terms of path difference? Path difference between the two waves should be equal to n lambda. Path difference between two waves should be equal to n lambda. So let us say this is equation 1. For constructive interference, delta x will be equal to n lambda. Delta x is path difference. But also we have discussed here by symmetry. By symmetry, this path difference is also equal to d sine theta. D sine theta. So if this is, and we also, we can also, we have to write it as also path difference delta x is equal to d sine theta. But here we have to write here, because for for d much greater than small d, theta will be small. Theta is equal to, theta will be very small, very small. For smaller angles, sin theta will be approximately equal to theta, and tan theta approximately equal to theta. That implies sin theta can be approximately equated to tan theta. Now here this already we have obtained. For small angles, sin theta is approximately equal to theta, tan theta is approximately equal to theta. We can take sin theta is equal to tan theta, which is nothing by from triangle, from triangle OPQ. OP, this is Q. From from triangle OPQ, we can say tan theta is equal to opposite side by adjacent side. Opposite side is OP. You have taken this as a position of the, if you are discussing about constructive interference, this gives the position of bright fringe. Bright fringe yn, a position of nth bright fringe. You can take ynb also. And opposite side is this, adjacent side is nothing but this distance d. So tan theta equal to yn by d. So in place of sin theta here, we can keep tan theta, which is nothing but yn by d. So in triangle OPQ, tan theta is equal to OP by OQ, which is nothing by yn by d. This we have substituted here. So this, if you keep it here in equation 1, and if you bring it here down, where? So here in place of sin theta, if you bring the tan theta, that is yn by d, right? So here the subscript we have taken b, that is not into b, don't confuse this. I have to take this as d into sin theta. I have taken it as yn by capital D. For constructive interference, we are considering this as the distance of the bright fringe. So suffix b we have taken. Suffix b means for bright fringe.
Bright fringe.
For bright fringe. So it's because of this. So now d into this by d is equal to, this is delta x. This is also delta x. Let us say this is equation 2. This is path difference. This is also path difference. From the equations 1 and 2, from 1 and 2, left hand side parts are equal, delta x and delta x. If you equate right hand side parts, you will get d into yn by capital D is equal to n lambda, is equal to n lambda. So and by using this and simplifying this, we can find the position of bright band, which nth bright band. Position of nth bright band. Here yn represents position of a distance of distance or position of nth bright band from central maximum, from central fringe or central maximum, any word you can use. So this is given by yn b, or simply yn is equal to, if you cross multiply this, n into d lambda, capital D lambda by small d comes here. This gives the position of bright fringes. So first bright fringe, if you want, n is equal to 1. And here n takes 0, 1, 2, 3 and so on. 0 represents what? N equal to 0 represents central bright fringe. And here, where n is equal to 0 represents central bright fringe or bright band. So we will get one central bright fringe, then alternate bright fringes on up and down. So we can call them as 1, 2, 3 bright fringes. So those can be obtained by using these positions. And it is observed that for first bright fringe will be obtained at d lambda by d, second one at 2d lambda by d, third one 3d lambda by small d, and so on. Whereas where we will get the dark bands? When you will get dark bands? For destructive interference. So for destructive interference, path difference is nothing but, already we have discussed, delta x is equal to 2n minus 1 into lambda by 2. Let us consider this is equation 1. And also delta x is equal to d sin theta. Here again, from the figure, by symmetry, then sin theta is equal to tan theta, which is equal to yn by d. For dark bands, we consider this is corresponding to dark bands. Okay, so and again, if you consider this is equation 2, and if you equate this, let us say this d is subscript. Don't confuse, this d and this d. This is for dark bands. Okay, or you can consider this as dark. Here also dark. Okay, then no confusion. So on equating this, you can say d into yn dark by capital D is equal to 2n minus 1 into lambda by 2. We want yn, so yn for dark bands. On simplifying this, we can get yn dark is equal to 2n minus 1 into d lambda by 2 into small d. So this gives the position of nth dark band. Means we first or second or third provided n is equal to 1, 2, 3 and so on. For bright fringes we have taken from n equal to 0, 1, 2, 3. Because bright band is obtained at center also, center of the screen, but the dark bands will not obtain at the center. So we cannot take here n equal to 0, n equal to 1, 2, 3 and so on, n equal to 1, d lambda by 2d, 2, d lambda by, you can say 3d lambda by 2d. What you can understand from this is, if a position of bright fringe is, first bright fringe is d lambda by d, then position of dark fringe, that means from central fringe, next bright fringe will be at a distance of d lambda by d distance, if for n equal to 1. Whereas the first dark fringe will be at
half lambda d by
yes,
2.
d
So
lambda by d by 2.
By 2.
Means if this is the screen, this is central fringe, at this d, this is d lambda by d. If we take it as 1, this is 1. The for first dark fringe will be obtained. If n equal to 1, you will get d lambda by d is 1. If you take 1 by 2, that means here you will get dark band. If this is first bright, first dark will be here. Means in between central bright and the first bright you will get dark. Like that. Next the second bright will be obtained here, B2. In between these two, you will get next dark. Second dark. Like that you can understand from this positions. You can cross check that. Okay, so but that you have just cross check and you have to understand everything. The detail, every point by point you cannot discuss. Just you have to understand. Okay,
Yes, sir.
so now by making use of this, we will discuss one more very important point, that is called fringe width. What is that?
Fringe
Fringe
width.
width. So here fringe width is represented as beta. Fringe width is represented as beta. So it can also be defined as distance between any two successive bright or dark fringes. Any two successive means just coming immediately coming.
Next.
So that means here if you see this the again, if you see this diagram, central bright, then next dark, then bright, then dark, then bright comes, right? The distance this is one bright, next bright, so next dark will get next bright. Distance between successive bright fringes, not this first, this is first, this is second, next third will come, right? With three, distance between first and third we are not considering. Successive means the next bright is called fringe width, or from center to the next, not between center and the fourth something, fourth or fifth. So this is, that is the meaning of successive. So distance between any two successive bright or dark fringes, even dark fringes also, successive bright or dark fringes is called fringe width. It is denoted by beta. How to find the expression for beta is, if you can, for example, let us consider position of nth bright fringe. Nth bright fringe is n into d lambda by d. So the one which is coming before nth bright fringe is n minus 1th fringe. So n minus 1th bright fringe position is n, in place of n if you keep n minus 1, you get it. So n minus 1 into d lambda by 2. The distance between them, if you want, simply this is something like this. If this is nth one, this is n minus 1th one. What is the, what is y means? The distance of that from central fringe. Central fringe. So if you want this distance, that is beta, you have to take this the total distance from center to here, then if you subtract this, you will get this one. So if you take yn and if you subtract yn minus 1 in this, then we will get beta. So we can say from this beta is equal to yn minus 1, it is equal to yn is n d lambda by d, yn minus 1 is n minus 1 into d lambda by d. If you expand this, you will get n d by n d lambda by d minus n d lambda by d, in minus of minus plus 1 into d lambda by d. This gets cancelled, you get d lambda by d. This is the expression for fringe width.
Fringe.
Fringe width, either a dark band or bright band. So it is observed that this fringe width depends on, directly proportional to distance between the slits and screen, and it is directly proportional to wavelength. If wavelength increases, fringe width also increases.
Increases.
And I can say it is also depends on the slit separation. If slit separation is inversely proportional, slit separation decreases, it may increase, and vice versa. So, so that is what you have to understand the parameters on which it depends on. So these are few points, and here this is the fringe width for a given fringe pattern. If this entire setup is simply immersed in a liquid, fringe width is nothing but some thickness, right? In a liquid having refractive index, then you have to say that fringe width in a liquid or in a medium can be expressed as beta dash will be equal to beta in air medium. You can take it beta simply or beta naught in air medium divided by mu. So you can also express this as d lambda by mu into d. Also you can express this is fringe width in a medium. This is equal to fringe width in a medium. Fringe width in a medium. This till here, this we have discussed. So if you, by remembering all this, we can go through some numericals. So have you practiced those numericals? So wave optics, right? So level 2, exercise 2. Some simple numericals. By level 2, exercise 1. Let us see this question number 1, page number 232. 232. So what is given here and what you are asked to find, and by making use of the points which we have discussed, how to deal with this. It is given that in Young's double slit experiment, the intensity of light at a point on the screen where the path difference is lambda is k. The intensity of light at a point where path difference is lambda by 6 is what? So what is given here? What is given here? In Young's double slit experiment, intensity of light, usually we have to remember the general formula for intensity of light in interference. So this you have to just, I will give you once again a little briefly here. Intensity of light. So intensity and amplitude are related. In interference concept we have discussed before that. So we have to remember that if when two waves interfere, resultant amplitude is given by AR is equal to square root we will take. Otherwise, if you take this square only, AR square is equal to A1 square plus A2 square plus 2A1 A2 to A1 A2 cos phi. To a1 a2 cos phi or cos theta, whatever it is. Here phi is the phase difference between the two waves of which these two are amplitudes. Here a1 is amplitude of the first wave, amplitude of a second interfering wave. When two waves are interfering, like when two waves are interfering, this is first wave and this is second wave. When these two waves are interfering at a point P, is y1, this is y2. Y1 is equal to a1 sine omega t plus phi 1, is a2 sine omega t plus phi 2. The resultant is capital A sine omega t plus phi. Phi is phase difference between those two, or phi 1 phi minus phi 2 you can consider. So this, if it is the resultant wave, is equal to vector sum of the two waves y1 plus y2. If it is equal to a, the amplitude of resultant wave into sine omega t plus phase difference between this. Phi is phase difference between the two waves. Phi is phase difference between two waves means phi 1 minus phi 2 or phi 2 minus phi 1. So that is this. And then resultant amplitude is given by AR square equal to this, or AR is equal to square root of this. Similarly, as because intensity of a wave is directly proportional to amplitude square of resultant wave gives intensity of resultant wave. So intensity of resultant wave, it is equal to square of amplitude of first wave gives intensity of first wave I1 plus square of amplitude of second wave gives intensity of second wave, plus here if I is proportional to A square, then A proportional to root I. Yes, then I proportional to square means A square proportional to I, or A proportional to root I, or I is equal to some equal to root I. So you can say 2 into A1 is square root I1 into root I2. You can write it as square root of I1 I2 into cos phi. Cos phi will be out of the root, not inside the root. Okay, so this will be the expression for resultant intensity. If here in double slit experiment we have considered two coherent waves. Coherent waves actually we considered as having same frequency and constant phase difference, provided we consider for getting maximum and minimas, we consider equal amplitude waves and hence equal intensity also they will have. So if I1 is equal to I2, which is equal to, let us say, I0, then IR can be expressed as I0 plus I0, I0 plus I0 plus 2 into square root of I0 into I0 is I0 square under root I0 square into cos phi. Okay, this I0 square, if it comes out, it becomes root, and I0 square comes out, it becomes I0. So 2 I0 plus 2 I0 into cos phi. If we to take this 2 I0 out, this is 2 I0. Here this entire thing is one term. So this will be 2 I0 cos phi. So this 2 I0, if we take this out, we will get 2 I0 into 1 plus cos phi. This is intensity of resultant wave. This can also be expressed as, this is equal to 2 I0 into 1. This is actually, in terms, if you consider this as 1 plus cos 2 theta form, 1 plus cos theta, you can write it as 2 cos square theta, cos square theta. If it is 2 theta, then you will get
Cos square
2
theta by
cos square theta, or here if it is 2 phi, you will get phi here, because this is phi. If it is in the 2 theta form, half of the angle you will get here. If it is phi, half of the angle will be phi by 2. So you will get 2 into 2 is 4. So you can get the intensity of resultant wave will be 4 I0 into cos square phi by 2 we will get. This you have to keep in mind. Okay, this will be the intensity of resultant wave, or resultant intensity of the superposed wave. Right? Attended this? Yeah. So now we'll make use of this here. According to this, what is this question here is? Yeah, this one, right? In the Young's experiment, the intensity of light at a point on the screen where path difference is lambda is k. Where path difference is lambda is k. Here, what you can understand from this is the resultant intensity depends on phi. Phi is phase difference between two waves. If the phase difference is zero and uh, like multiples of integral multiples of 2 pi, then you will get maximum intensity. We call it as the constructive. And if it is odd multiples of pi, 1 pi, 3 pi, and so on, we'll get zero destructive interference, zero intensity. So so we can say that intensity depends on phase difference, but phase difference also depends on path difference. So you can say intensity depends both on phase difference and path difference. So here, according to this question, what you can say is at a point, at a point as intensity at a point, you can take it as first point as IR1. Intensity of resultant intensity IR1 is equal to K. What is that? The intensity of light at a point on the screen where the path difference is lambda is K. The intensity of resultant wave is K when path difference, which is denoted by delta x, is lambda. When path difference is lambda, intensity is K. Intensity is K. Then what should be the intensity of the wave at some point where path difference delta x is equal to lambda by 6 is the question. How can you relate this is, as we know, as intensity of resultant wave is 4 I naught into cos square 5 by 2, 5 by 2. This phi is phase difference. If you can express this in terms of path difference, how can you express? Because phase difference delta phi is equal to 2 pi by lambda into path difference delta x. You can write it as instead of delta phi is equal to 2 pi by lambda into x. So where you can, if you replace this here, then you can write this is equal to 4 I naught into cos square. Phi can be expressed as 2 pi by already 2 is there, 2 lambda into x, delta x or x. Here 2 cancel, got it? So you'll get this is general expression for intensity in terms of phase difference. This is in terms of path difference. So you can write it as IR is equal to 4 I naught, sorry, 4 I naught, 4 I naught into cos square pi by lambda into x. This is general expression for intensity in terms of phase difference. This is general expression for intensity in terms of path difference. In terms of path difference. Now here path difference is given. In terms of path difference, how to find intensity we want, right? So here first case is if path difference x is equal to lambda, intensity is k, right? IR1, if x1 is lambda, IR1 is equal to k. Then what you are going to get, let us try to understand. If you substitute this here in this, you can take this for first case, it is you can take that ratio also directly and you can compare. That is also, otherwise step by step you can do. So IR1 is equal to 4 I naught into cos square pi by lambda into x1. Okay, so IR1 is k, right? Let us take this as k is equal to 4 I naught into cos square into pi by lambda. X1 is what? Lambda. Lambda cancel. Cos pi is how much? This can be expressed as 4 I naught into cos square pi. You will get cos square pi can be expressed as cos pi whole square. Cos pi whole square also you can write. Cos pi is -1. So you can write this as 4 I naught into -1 whole square. Got it? So -1 square is 1. So you can write k is equal to 4 I naught. So by using first condition we have got k value as 4 I naught. Why we need this we will understand in the while doing the second part. What is given, what you are asked to find is if path difference x is equal to lambda by how much? 6. then what will be the resultant intensity in the second case is the question. So what is the relation between the intensity and the path difference? We know that IR2 is equal to 4I0 into cos square pi by lambda into x2. X here in case of this we take it as x2. X2 is this, then IR2 is what? So if you substitute this, what you will get? Let us say this is equal to in a single line we'll do here as much space is there. So it is equal to 4I0 into cos this entire cos square of this angle can be expressed as this cos of the angle into whole square pi cos pi by lambda into x is how much? Lambda by 6 whole square, right? Whole square. Now lambda gets cancelled. This further can be expressed as 4I0 into cos pi by 6. Cos pi by 6 whole square. What is cos pi by 6? Pi by 6 is 30. Cos 30 is root 3 by 2. Right? Root 3 by 2 whole square. 4I0 into root 3 by 2 whole square. Root 3 by 2 square is 3 by 4. So 4I0 into 3 by 4. But here in the options they have given the final result in terms of k. So but we know 4I0 is k. 4I0 is k. So if you replace this, then you will get IR2 is equal to k into 3 by 4 or 3k by 4. This is how you will get. Or simply directly here itself, just for understanding, I am giving you everything step by step. So I may be taking more time. Once you understand this, you have to do very quickly. The time management is also very important. So how can you do directly is as you know as we know that intensity in terms of path difference is IR is equal to 4 I naught into cos square, what is that, pi by lambda into x in general. So IR2 we want, right? IR2 by IR1 is equal to 4 I naught. Hmm? So actually yes,
It can cancel.
hmm. It can be,
Cancel.
yeah, it can be cancelled, but here already just we have taken this IR1 as k.
Okay, sir.
So that is that way you can take it. So you can take this as 4 I naught into cos square pi by lambda into lambda by 4 I naught into cos square pi by lambda into lambda by 6. So lambda cancel here, lambda cancel pi, so it is, this also gets cancelled. Cos square of pi or cos pi whole square, cos pi is minus 1 whole square divided by this is pi by 6. Pi by 6 is root 3 by 2 whole square. So it is equal to, it is 3 by 4. 4 goes to
4 by 3.
numerator. 4 by 3 is IR2 by IR1. But what you are getting, IR2 by 1, right? IR2 is equal to 4 by 3. 4 by 3 into IR1. IR1 is k. So you can take it as 4 by 3 k. Is it 3 by 4 k or 4 by 3 k?
3 by 4. 3 by 3.
Here just we have taken reversely. IR2 is this lambda by 6 taken reversely. This is lambda. So this will be root 3 by 2 whole square. This is minus 1.
Minus 1.
So taken reversely. So yeah, this will be lambda. This is lambda by 6. So it will be minus 1 whole square. So you'll get 3 by 4. 3 by 4. So 3 by 4. And so therefore you'll get here also 3 by 4 accordingly. So 3 by 4 IR1. So 3 by 4K
4K.
you'll get. So just you should be able to understand how to do quickly. So the same thing we did in 10 seconds. So that you should, but once you understand, you should be able to further you have to improve. Okay, how to do it quickly. So that will come depending on your practice.
Yes.
Again and again, maybe 3 times or 5 times. So if you, how many times you practice, you will get your new ways. You can you'll discover new ways of doing sometimes. So then you can handle the time management properly. So then if you see this next second one, question number 2, it is given that in a Young's double slit experiment, d equals the distance of screen and small d the separation between the slits. The distance of the nearest point to the central maximum where the intensity is same as that due to single slit is equal to. So what is that? So overall, after reading this, what you have understood is, of course, in the double slit experiment, capital D is distance between slits and screens, and D is the distance between separation between slits. Okay, first sentence done. Second sentence says what? The distance of the nearest point on the nearest point to the central maximum, where the intensity is same as that due to single slit. How to express this? So you have to just recollect back quickly this this setup, experimental setup. Somewhere this is O, somewhere here from the central maximum. This is the distance. The distance of the nearest point to central maximum. Let us say this is Y. Distance, the distance of the nearest point. This is the point, nearest point Y to the central maximum, where intensity due to this interference, resultant intensity due to interference is same as that due to single slit. Single slit means single wave. This is equal to I naught. We know IR is equal to 4 I naught into cos square 5 by 2. This is equal to I naught. So if this is at this, what is the point where resultant intensity equal to intensity of this? That means what is the point, means what is the distance. So what is the distance where IR is equal to I naught, or this is equal to I naught? To understand this, you should think about how to get this position of you are not clear about whether it is a dark fringe or bright fringe or something is not that kind of information is not given, then you can say directly. But here in general, you can say you try to find by simplifying this what you will get. Let us try to understand. You will get, if you cancel out this, only the remaining factor is 5. So you can, will get 5 called as phase difference. So you can write from this as cos square 5 by 2 is equal to 1 by 4. 4 comes here, and hence cos 5, if you write square, if it's on this side, it becomes 1 by root 4. It is 1 by 2. So cos 5 by 2 is equal to 1 by root 4 is 1 by 2. So 5 by 2 is equal to, for what angle of this you will get 1 by 2? For cos 60 degrees. 60 degrees in terms of pi radians, you can write it as pi by 3. So 5 by 2 is pi by 3 radians. Then means 5 is equal to 2 pi by 3 radians. So for this phase difference, we'll get this condition. If that is for that phase difference, means what will be the corresponding path difference? You have to think about. Why you have to think in that ways? You have to think about how to relate this with y. Phi with y. We know phi phase difference is equal to 2 pi by lambda into path difference. Path difference is delta x or x. Delta phi, delta x, phi x. But path difference can also be expressed as, also path difference is equal to 2 d sin theta. From symmetry, for smaller angles, you can write it as sin theta is tan theta. It is equal to d into y by capital D. You substitute this here, then you can write what is this? Phi is equal to 2 pi by lambda into x can be replaced with this. What is this? D here d into y by capital D. Depends on the two options. In what terms you want. Here here it is mentioned that in terms of capital D small d lambda. That's why you are supposed to replace with this. Then what you want? This one, right? Here what is phi? 2 pi by 3. This is, let us take this is 1. But you have to say, but phi is equal to this, and hence we will get this equation 2. Here phi is this, phi is this. From equation this to from these two equations, left hand side are equal. If you equate this to 2, then you can write 2 pi by lambda into d into y by d is equal to 2 pi by 3. And if you simplify, you get y. So 2 pi cancel. So y is equal to d lambda goes here. So y is equal to d lambda by 3 is this, d comes here, 3d. This will be the position. Okay. This is why just you have to work out this kind of questions.
Yes, sir.
Right. So the next question is a direct question. We're asked to find wavelength. So just try to work out these questions. In the next session, we'll discuss about how to find the path, the change in path difference when a glass slab is introduced in the path of interfering light. The next session we'll discuss that. Then if that is complete, some method of questions, related method questions will work out. Then we'll discuss diffraction. Okay. Go through similar kind of questions are there in the next exercise. First exercise also.
Yes, sir.
Finish this.
Thank you, sir.
Second. This one. Second. Second. Is mentioned here. So y is equal to y equal to x. I'll tell you this one. Yes. I will tell you later this. The path difference between two interfering waves defined on the screen is lambda by 6 from the central line. The ratio of intensity at this point and that at the central fringe. Ratio of intensity, sir. Direct one, right? Sir, with the repractice we not completed. That is, we can say directly also. Actually, it's not a big and lengthy concept. It is simple one. Let us see the question. What is given? So, the question number 6. Question number 6. Page number 225. So, it is given that the path difference between two interfering waves at a point on the screen is lambda by 6. Path difference is delta x, or simply you can take x is equal to lambda by 6 from the central maximum. The ratio of intensity at this point. So let us say this is the first position, something like this. Okay. Or actually, with respect to central layer asked, right? So let us say this is second position. X2 is this. Then ratio of intensity at this position, let us take it as I2. I2 or IR2. Ratio of intensity at this position is IR2, and the ratio of intensity at this position and that at the central fringe will be that at the central fringe. And the central fringe, let us take it as IR1 is equal to what? So we have to take the general formula of IR. IR is equal to what? IR is equal to 4 I naught into cos square 5 by 2. So now let us take directly IR2 by IR1 is equal to IR2 is 4 I naught into cos square. In terms of path difference also, path difference is given, right? So let us take this in terms of path difference. This 4 I naught into phase difference is phi is equal to 2 pi by lambda into x. So 2 pi by 2 lambda, so 2 cancel into x. So lambda by pi into x, right? So you can write it as 4 I naught into cos square pi by lambda into x2 divided by 4 I naught into cos square pi by lambda into x1. So it is equal to 4 I naught gets cancelled. We get cos square of cos square pi by lambda into x2 is lambda by 6 by cos square into pi by lambda into at central maximum. What will be the path difference? For construct at central maximum is a right fringe. Yes, so condition for right fringes in terms of lambda is n lambda. At central maximum n equal to 0. Path difference is 0. Yes, 0. Then we can take it as this entire thing is 0. Cos 0 is 1. Cos 0 is 1. So here lambda lambda cancel. Pi by 6. Pi by 6 is 30 degrees. Cos 30 is root 3 by 2. Whole square is 3 by 4. So here it is in terms of the values they have given. So actually we have to consider that we should also know one more point. We'll see that. So here IR2 by IR1 is equal to 3 by 4. So from this, directly a ratio only are asked, right? So 3 by 4. So 3 by 4 means it is point 30 means 4 7 is 28. 4 7 28. 2 into means 4 5s. 0.75. 0.75. That's it. So this will be the ratio. So you should remember the expression for intensity of resultant wave in terms of phase difference, in terms of path difference, both. Remember this. This is very important. Okay, that's it. Then what is going here? A double slit apparatus is immersed in a liquid of refractive index 1.33. It has a slit separation of 1 mm and the distance between the plane of slits and screen is this. Slits are illuminated by a parallel beam of light whose wavelength is this. Then fringe width is the direct one only. Only refractive index.
Yes, so refractive index they have to multiply it.
Actually, you have to length, thickness.
Yes, sir.
So what you have discussed at the distance travel. Well, if a light is traveling, something like in ray optics, how we have discussed, the same phenomena is applicable here also. So what is that? If what do you call real depth, apparent depth kind of concepts. So if a medium is traveling in air without medium, what do we call it as real depth? Actually, actual distance, because of the refractive index, it will decrease. So fringe will decrease by refractive index times. So I would say question number, what is this, 8. uh, Fringe width beta is in air, you can take it as beta naught, it is equal to d lambda by small d. Beta in a medium, you can take it as beta prime or beta 1, whatever it is equal to beta naught by simply mu. So d is given, lambda is given, small d is given. Calculate this. Then find out by mu. That's mu also given. So if you calculate this, it is observed to be 0.63 mm. 0.63 mm you will get. All values are given here. So d is given as separation, slit separation is small d is 1 mm, and refractive index mu is given as 1.33, and distance between the planes of the slits and screen is also 1.33. For calculation purpose, easy calculation purpose, you can use this. 1.33 gets cancelled out. So, and lambda is given as 6,300 angstrom units. Angstrom units. You can write it as 63 into 10 power minus actually 63 into 10 power minus 8 minus 8 you can write in meters. All should be in SI units. Then you can write in millimeters. At the end you can convert. Okay. So this way you can. Yes. Yes. Okay.
Thank you.
Right. Question number. Page number 231. The question is, in inks, the question is, in inks double slit experiment, the fringe pattern is observed on the screen placed at a distance d, capital D. The slits are illuminated by light of wavelength lambda. The distance from the central point where the intensity falls to half half the maximum is. So no need to give the options, you can try. So what is given here? The first point says that in Young's double slit experiment, the fringe pattern is observed on a screen placed at a distance capital D. Okay. The slits are illuminated by light of wavelength lambda. Okay. The distance from the central point where the intensity falls to half of the maximum is. So, if you observe this, S1, S2. So if somewhere here, if you consider this is central point, somewhere here, if you consider observing the interference, this is point P. Then the question is the distance from the central point, distance of this point from central point. If you say this is y, where the intensity at this point falls to half of the maximum. Maximum will be at this point. I can say half the maximum. So usually, intensity of the resultant wave is IR is equal to 4 I naught into cos square pi by 2 in terms of phase difference. In terms of path difference, I by lambda into x. Okay, so you have to remember that also. Here, intensity, what you are asked to find the distance. What is this distance where intensity falls to half of the maximum? Intensity here, let us say central point is intensity, let us take it as IR1 is equal to 4 I naught. Here, let us say it is IR2. Here it is mentioned that at some distance, what is the distance we don't know, at some distance, intensity falls to half of half of the maximum, that is IR1 or 4 I naught. So what is the distance? We are asked to find. So IR1, if IR1 is 4 I naught, then what should be IR? Sorry, not what should be IR2. For IR2 should be half of IR1 or half of 4 I naught. What should be Y? Is the question. So you have to say as IR is equal to 4 I naught into cos square 5 by 2. You have to say IR should be here for the second point you can take IR2 is equal to this. But IR2 can be taken as half of 4 I naught half of IR1. So 4 I naught by 2 is equal to 4 I naught into cos square 5 by 2. So 4 I naught gets cancelled. Go to another bench. 4 I naught by 2 is equal to 4 I naught into this. So we will get cos from this cos square 5 by 2 is equal to 1 by 2. So from this you can say cos 5 by 2 is equal to this. To send this square here it becomes 1 by root 2. For what value of cos we get 1 by root 2 for 45 degrees. So 5 by 2 is equal to 45 degrees means pi by 4 radians. From this you can say phi is equal to 2 pi by 4. 2 pi by 4. But what we are asked to find? We are asked to find y. We got 5. Then how can we get y? We have to think about. So we know that from this delta x is equal to lambda by 2 pi into delta phi, that is phi here, x is equal to this, okay, and so this is equal to lambda by 2 pi into, for this condition phase difference should be 2 pi by 4, so we'll get lambda by 4, so delta x is equal to lambda by 4. Let us see, this is equation 1. But also we know that delta x will be expressed in terms of y. How it is d sin theta. For smaller angles, d sin theta will be equal to tan theta, that is equal to d into y by d. So let us see, this is equation 2. Left hand sides are equal, right hand sides should be equate, then you will get from, I am explaining step by step, but you have to do quickly without doing all this. From 1 and 2, you can write d into y by d is equal to lambda by 4. This is y is equal to d lambda by 4d. D lambda by 4d. Nothing but central maximum. Okay, we have to understand that. If beta is the bandwidth or fringe width, the minimum distance between the 2 points on either side, minimum distance between the 2 points on either side of the between 2 points, between these 2 points on either side, this side or this side, on either side of the bright fringe, where the intensity is half the maximum intensity is. How to understand this? Let us say, where what you are asked to find the minimum distance in this diagram. If you see the minimum distance between 2 points, what are the 2 points? The maximum intensity point and the point where intensity is half of the intensity at maximum intensity point. We take it as a first point, or IR intensity at the first point, resultant intensity at first point. IR1 means resultant intensity at first point, or what do you call it, zero order point. IR2 means resultant intensity at second point, that is at point P. Okay, so at what minimum distance between these 2 points, intensity becomes half of the maximum intensity here at zero order, uh, zero order bread fringe is the question. So intensity, resultant intensity at any point is given by 4 I naught cos square phi by 2. 4 I naught 4 I naught cos square phi by 2, right? And it is equal to half into maximum intensity at the zero order point is nothing but 4 I naught. 4 I naught. So if you substitute this and you can simplifying further, you get 4 I naught, 4 I naught gets cancelled. Then cos square 5 by 2 is equal to 1 by 2, or you can write cos 5 by 2 by sending this square this side, it becomes 1 by root 2. So cos 5 by 2 is equal to 1 by root 2. So this further can be expressed as for what angle we get 1 by root 2 for cos is for 45 degrees or pi by 4 radians. So 5 by 2 equal to pi by 4 radians, or phi is equal to 2 into pi by 4, or 2 pi by 4, or you can say pi by 2 radians. So the corresponding at the for this phase difference will get, if the two waves interfere at a point with this phase difference, then intensity at this point will be half of the maximum intensity at central bread fringe. Then next point is you are asked to find the distance. So you have to consider one relation which is having this distance term. So here we don't have any distance term. So for that purpose, let us consider the corresponding path difference. Corresponding path difference is given by as the relation between phase difference and path difference is delta phi is equal to 2 pi by lambda into delta x, or delta x is equal to lambda by 2 pi into delta phi. Here delta phi is this 2 pi by 4 or pi by 2, anything you can take. So it is delta x is equal to lambda by 2 pi into 2 by 2 pi by 4. If you take 2 pi 2 pi gets cancelled, 2 pi by 4 if you take 2 pi 2 pi gets cancelled, you get lambda by 4 is the path difference, corresponding path difference to give that intensity relation. So delta x is equal to lambda by 4. Let us take this as equation 1. But also path, again you want to find the distance, minimum distance at that point. Why? So how to understand that again? So we have to get one relation which is involving y. So for that purpose, let us say again we also know that path difference delta x is equal to d sin theta. For smaller angles, sin theta is equal to tan theta is equal to y by d. So we can write dy by d. Here we have y, path difference in terms of y. So if we take this as equation 2, from these two, as left hand sides are equal, if we equate right hand sides, we get dy by d, small dy by small d into y by capital D is equal to lambda by 4. On simplifying this further, we will get y. So y is equal to cross multiply and break, send all the terms this side, then we will get y is equal to capital D lambda by 4 into small d. So but here d lambda by d is nothing but Fringe width. We know that, and because beta equal to d lambda by d, capital D lambda by d is Fringe width. If you substitute this here as a beta, then you will get y is equal to beta by 4. This is the minimum distance on either side of the bright fringe, where the resultant intensity will reduces to or falls to half of the maximum intensity. Okay, that is how you have to understand this. Okay, so I'm winding the session now. Okay, take care everyone. Bye.